Welcome back to lecture number 35. We are continuing with Laplace transform properties. So in the earlier lecture we are finished off with sum number 16, now sum number 17. So we have finished off these 6 properties. Now we will see the convolution in time property. Sum number 16. Find output of system LTI, just input as fine. So they are giving us a system, an LTI system, which has an impulse response h of t, given us x of t, and we have to find the output y of t. This is a very common question that always comes in different ways. You have to find output of LTI system y of t for given x of t and h of t. Fine. We all know y of t is x of t convolution h of t. We know the Laplace transform from the property of convolution, that convolution in time domain is multiplication in the frequency domain. So we'll be using this property to solve the sum. Fine. Now let us write x of t. X of t is given as a graph now. How do I write x of t? How do I write x of t in terms of standard equations? Okay, we have seen this a lot of times. So you can see x of t is a rectangular pulse. H of t is also a rectangular signal over here. I can write x of t as u of t minus u of t minus 4. Okay, we have done this a lot of times. Same way, h of t is u of t minus u of t minus 4. So now if we take the Laplace transform, what do we get? What is Laplace of u of t? 1 by s. Laplace of u of t minus 4, yeah, shifting property, right? So e raised to minus 4s, e raised to minus s t naught upon s. Multiplication, convolution becomes multiplication, and 1 by s e raised to minus 4s upon s. So what do we have? If we multiply it, you will get y of s is equal to 1 upon s squared minus 2 e raised to minus 4s upon s squared plus e raised to minus 8s upon s squared. Just multiply both these terms together, you should get this thing. Fine. Last step, find output. So inverse Laplace transform. Y of s inverse Laplace is y of t. 1 by s squared inverse Laplace is t u of t. Right? We have seen this. This is going to be, you have 1 upon s squared, so you will have t u of t. Along with that, you have minus e raised to minus 4s. So that is shifting the time domain. So you will have 2. You should have t u of t, right? But you have this extra term over here. So how will you negate the effect of this? You will say t minus 4 u of t minus 4. Yeah, you can check back the sums which we have done. This is shifting in time domain plus same thing over here, t minus 8 u of t minus 8 and that is your final answer. Alright, how have we done this? This is by the property that we have used, that is x of t minus t naught Laplace is e raised to minus s t naught capital X of s. Okay, you can go and check by the sums for this. Quite simple. Next sum number 17. Very easy sum. Y of t plus 0 to infinity. It will be put like this: infinity y of tau x of t minus tau d tau is equal to x of t plus delta t. You have to find y of t. Yeah, first thing, what does this thing look like? This is the formula of your convolution, okay, of your time domain continuous time convolution. So you can write this as y of t plus, what is the entire term? This is a convolution term, x of t convolution y of t. Yeah, the same remains as it is. Let us take the Laplace transform of this. So y of t is y of s plus convolution time domain is multiplication in the frequency domain. This is x of s. What is Laplace transform of delta t? 1. So what do you have? Therefore y of s 1 plus x of s is equal to 1 plus x of s, right? Both cut, so you have y of s is equal to 1. Yeah, so what is inverse Laplace transform of y of t? What is one inverse Laplace transform? Delta t. So your y of t is this. Cool? Yeah. Next sum please, sum number 18. d by dt of y of t plus 4 y of t plus 3 okay. So how do I solve this? I need to find h of t. Alright, your system is LTI, input is x of t, output is y of t. Same thing as last. So whenever you find terms like this, an equation like this, best is straightforward, take the Laplace transform. Okay, what is d by dt Laplace transform? D by dt y of t, it is, yeah, it is s y of s. Very good. Plus, what is 4 y of t? 4 y of s. Now this is a property, this is your integration property. We have not done this as such, but just for you to remember the answer for this term. So whenever you have integration in time domain, the Laplace is y of s upon s. Yeah, please remember this thing. This is one property extra which does not come a lot of time in the exam, but it is good to know. And what is x of t Laplace? X of s. Therefore just get all the y of s on one side, get all the x of s on the other side. You will get y of s upon x of s is 1 upon s plus 4 plus 3 by s. It comes out to be s upon s square plus 4s plus 3. That comes out to be s upon s plus 1 s plus 3. You can do partial fractions and you will get, therefore y of s upon x of s is equal to a upon s plus 1 plus b upon s plus 3. And get a and b value, you will get minus half upon s plus 1 plus 3 by 2 upon s plus 3. So therefore you get y of s upon x of s. Have you got the answer? No. Okay. What is asked? H of s is asked. H of t is asked. Sorry. H of t is asked, and you have got y of s upon x of s. Right. Okay. Now, if I have a system h of t, if my input is x of t, output is y of t. So what is y of t? If system is LTI, x of t convolution h of t. So if I take Laplace, it is y of s is equal to x of s h of s. Therefore, what is y of s upon x of s? It is h of s. Use this in your previous sum, previous equation. So y of s upon x of s comes out to be h of s. Great. Yeah. So you can say therefore h of s is equal to minus half upon s plus 1 plus 3 by 2 upon s plus 3. Take the whole Laplace inverse Laplace transform. What is h of s inverse Laplace transform? H of t. What is minus half s plus 1 transform? Minus half e raised to minus t u of t plus 3 by 2 e raised to minus 3t u of t. Good. Alright. So now for the system h of s, that is the Laplace transform of the impulse response. So therefore you can say h of s is equal to s upon s plus 1 s plus 3, right? And h of t is what you have found in the earlier thing over here, right? Now if I add one more question over here, if input to this system, that is this system, is x of t is equal to u of t plus delta t, find output. Alright, so this is a extra counter to this question. So you have h of s now, you have x of t, you are required to find output, that is y of t, right? So I have x of t, let me just cook out x of s. X of s is 1 by s plus 1. Fine. As I know, h of s is equal to y of s upon x of s, right? What is h of s? H of s is s upon s plus 1 s plus 3. I have got from over here. What is y of s? Don't know. What is x of s? I can write this as s plus 1 upon s. So x of s is s plus 1 upon s. Let's cut this. Let's cut this. So what is the y of s? So y of s is 1 upon s plus 3. What is y of t therefore? E raised to minus 3t u of t. Mark this as very, very important, this sum. Okay, it often comes into exam, very good sum to have, right? And so that takes care of convolution also. Alright, that takes care of the properties. Next we'll see a few two topics called as initial value theorem and final value theorem. Alright, initial and final value theorem. Okay, so you have two formulas over here which help you to find the initial value, that is x of 0. So initial value is x of 0 and final value is x of infinity. Okay, so value of singularity is equal to 0, value of singularity is equal to infinity, right? So the initial value theorem formula is x of 0, that is limit t tends to 0 x of t. Okay, so value of x of t at t is equal to 0 is limit s tends to infinity s into x of s. Similarly, final value theorem, x of infinity, that is limit t tends to infinity x of t is equal to limit s tends to 0 s into x of s. Okay, so these are two formulae. Please remember this and keep for initial value and final value. Let us do two sums on this, would be helpful for you in exams. First sum, x of s is 2s plus 5 s squared plus 5s plus 6. find initial value and final value. You will say, so initial value is x of 0. X of 0 is limit s tends to infinity s into x of s. So you know x of s, right? This 2s plus 5 upon s squared plus 5s plus 6. Okay, let us just divide the entire terms, both the terms, by s squared, so that it can be helpful. You will see how. So it comes out to be limit s tends to infinity. So dividing by s squared throughout, I will have 2 plus 5 by s. Okay, I have 1 plus 5 by s plus, alright. So s tends to infinity, you can replace the value of s over here. So we'll have 2 plus 5 by infinity upon 1 plus 5 by infinity plus 6. So what is 5 by infinity? 0, 0, 0. So what is the answer you get? Answer you get is 2. Therefore x of 0 is equal to 2. And what is the final value? X of infinity is limit s tends to 0 s into x of s. Okay, straightforward. You can say s into x of s. Nothing is going to cut, right? I'll just do it for you still. 2s plus 5. Okay, you cannot cut any of the you cannot cut this s term anywhere. You'll have to substitute over here inside. If you substitute s is equal to 0, you will get answer as 0. So x of infinity, this has to be continuous please. Okay, let us talk of the next topic called as causality and stability in Laplace transform. So if I talk about Laplace transform and the S-plane, from the S-plane we can understand whether the system is causal or stable. Okay, so it is going to be causal only and only if ROC is right of the rightmost pole for a proper transfer function, and the system or signal is stable only if ROC contains the j omega axis. Okay, let us check this out. So number 1, h of s is s minus 1 upon s plus 1 s minus 2. Alright, find h of t and ROC for different cases of stability and fine. So you have to find h of t and the ROC for different cases of stability and causality. And so h of s is given to us. Let us find h of s. It is s minus 1 upon s plus 1 s minus 2. Let's take the partial fractions. S plus 1. So the a and b values are, therefore h of s is equal to 2 by 3 s plus 1 plus 1 by 3 s minus 2. Yeah, that is my h of s. We just copy this and put it in the new page. Okay, let me draw the pole 0 plot for this, please. Yeah, the pole is at -1 and +2. Fine. Sigma j omega s plane. Alright, so let us take case 1. H of t, that is h of s, h of t is causal but unstable. Okay, so let us just do the first case over here. In my first case, let the ROC be like this. So you have two poles over here, one pole over here and one pole over here. In this case, you can say ROC is right of the rightmost pole. So the rightmost pole over here is 2. Fine. And ROC, you are saying let the ROC be right of rightmost pole. So as you have seen in the earlier condition, if the ROC is right of rightmost pole, I can say that h of t is causal. If that is the case, in this case, does the ROC contain j omega axis? No. So not stable. So my first case is causal and not stable. Right? What do you expect h of t to be? H of t is going to be 2 by 3. Okay. Inverse Laplace transform e raised to minus t u of t plus 1 by 3 e raised to minus 2t u of t. Right? Why do I have u of t? Because it is causal. So this takes care of my first case. Now the next case, please. Let me draw the S plane, please. A pole at -1, pole at 2. Let me take the ROC like this. Sigma is sigma and j omega. Sigma is more than -1 and sigma is less than 2. So sigma is more than 1. We have done these kinds of sums earlier also. Just a small revision. Sigma is less than 2. Fine. Okay. So case 2. What do I say? H of t. Okay, for h of t. ROC is not to right of rightmost pole, therefore not causal. Is it stable? Yes, because it contains the j omega axis. What contains? The ROC contains the j omega axis. And how do you get this kind of an ROC? We have done this earlier also. So just take inverse Laplace transform of h of s, you will get h of t. H of t. How do I get a thing like this? 2 by 3. When do I get an ROC more than -1? When it is e raised to minus t u of t. I have sigma is more than -1 plus, okay, 1 by 3. How do I get this kind of an ROC? Sigma less than 2, it is e raised to minus raised to plus 2t, sorry, u of minus t, and you should have extra minus also over here. You should have an extra minus, don't forget this extra minus sign over. Okay, so this gives me sigma is less than 2. Fine. So this is my h of t. This is h of t when signal is not causal. So is it non-causal or anti-causal? It is anti-causal. Okay. So signal is anti-causal and stable. Next case, please. We know the pole 0 plot is sigma and j omega. Pole is at -1, pole is at 2. If I draw this kind of an ROC, sigma is less than -1 and sigma is less than 2. So f of t for case 3, what do I reduce over here? I will say ROC is not right of rightmost pole, therefore not causal. I can say it is non-causal because signal will be entirely on the LHS. Is stable, not stable. Why? Because ROC does not have j omega axis. So how do I get the inverse Laplace transform for this h of s? H of t will be 2 by 3 minus of e raised to minus t u of minus t. We have done this some earlier, I will not dwell more on this. Minus 1 e raised to 2t u of minus t. So this gives us sigma less than -1, so sigma less than 2. Fine. So whenever you encounter some sums of this kind, have 3 cases and then solve it. Yeah, good. So only one topic is remaining for Laplace transform, that is unilateral Laplace transform. In the last part of the Laplace transform topic, we are dealing with a topic called as unilateral Laplace transform. Fine. So bilateral Laplace transform we have seen. X of s, x of t e raised to minus st dt. Over here we are taking the entire range of the signal x of t from minus infinity to infinity. For unilateral, as you must have guessed by now, x of s is going to be from 0 to infinity x of t e raised to minus st dt. Fine. So unilateral Laplace transform only takes the Laplace transform of signals that are on the right hand side of the domain, that is causal. Okay, mainly in maths we deal only with unilateral Laplace transform. For example, if I say find the Laplace transform of delta t plus 2, if you are doing bilateral, we'll have an answer. Our answer is going to be e raised to minus st naught into 1, that is e raised to 2s. This is for bilateral Laplace transform. But if I talk of unilateral Laplace transform, delta t plus 2. Now where does delta t plus 2 lie, guys? Yeah, delta t plus 2 lies, it's a left shifted signal. Delta t plus 2, it is at -2 location. So it is on the negative side, negative axis. Therefore, the unilateral Laplace transform of delta t plus 2 is 0, because ULT is only for causal signals t more than 0. Yeah. So for unilateral Laplace transform, there is just one property that we must know for our sum. Okay, just one sum comes, and which is very important. The property is called as differentiation in time property. For unilateral Laplace transform. For bilateral, what is the formula, guys? Differentiation in time is d by dt x of t. BLT is s x of s. This is the formula for bilateral, which we had seen earlier. But for unilateral, the formula is d by dt x of t is s into x of s, same as earlier, minus the initial value of signal x of 0. Understand, this is capital X, this is small x. D squared dt squared x of t. Okay, double differentiation is s squared x of s minus s into x of 0 minus x of 0 differentiation. Okay, for example, if I do d by d cube x of t, my answer will be x cube x of s cube x of s minus s squared x of 0 minus s x dash 0 minus x double dash 0, right? So general form I can write dn dtn x of t. General formula is s raised to n x of s minus s raised to n minus 1 x of 0 minus s raised to n minus 2 x dash 0 minus s raised to n minus 3 x double dash 0 minus so on and so forth s raised to 0 x of n minus 1. Majorly for your university questions you will just have these three differentiations to take care of. Yeah, so this is for bilateral, which you have seen till now, and this is for unilateral. Keep this in mind. We'll do one sum and that should be enough. Okay, the sum for unilateral Laplace transform is going to be a big sum. Yeah, please have patience. Okay, write down. Find the total response of system given by the differential equation y double dash of t plus 5y single dash of t plus 6y of t. Okay, it's double differentiation, single differentiation, and just y of t is equal to 2 x dash t plus x of t. And input x of t is equal to u of t and initial condition y of 0 is equal to 1 and y dash 0 is equal to 2. Okay, so this is a unique sum where they tell you to find the total response of system, alright, and you will be given a differential equation like this. Input is given and some initial conditions. Alright, before we start the sum, let us understand what is the meaning of total response. Total response of system. Alright, total response, what does it mean? You have seen in CTN also, circuit theory and networks. Whenever a system is switched on, it has some transient state and then it goes to steady state. So total response of a system is given by the sum of the transient response or we can say the natural response, or we can say the zero input response, ZIR. Okay, zero input. This plus what is opposite of transient? Not opposite, and you can say transient, then you can say steady state. Transient plus steady state response or natural, I can say opposite is forced response. Okay, here it was 0 input response, it is going to be ZSR, or 0 state response. Fine. So whenever you find a sum like this where they tell you to find the total response, you have to first find the transient response, then the steady state response. Right. So transient response, when you're finding transient response or 0 input response, important point to remember over here is that no input taken. All initial conditions are taken. For 0 state response, all inputs taken, no initial response, no initial conditions. Okay, fine. So let us just try this sum out by knowing these facts. Okay. Okay, so let us just copy this and keep. So this is a sum for me. I need to find the total response. Yeah, let us start. So this is my sum over here. First thing is I will find the transient response. Okay, transient response means 0 input response, or transient, or you can say natural response. Okay, so I will say transient response. Fine. Here input should be 0, that is x of t is equal to 0, therefore x of s also 0. Okay, and all initial conditions you will accept. Fine. So I am finding the 0 input response. Okay, so you have y double dash of t plus 5 y single dash of t plus 6 y of t is equal to 2 x dash of t plus x of t. There is a Laplace, unilateral Laplace transform. Okay, what is y double dash of t? Y d squared by dt squared of y of t. It is s squared y of s. Yeah, very careful. This term now, s squared y of s minus s y of 0 minus y dash of 0. Okay, so plus 5. What is y double y single dash of t? The d by dt of y of t. What is the unilateral Laplace transform for this? This s y of s minus y of 0 plus 6 y of t Laplace is y of s, y of Laplace y of s is equal to 2. What is x of x dash t? That is d by dt of x of t Laplace s x of s minus x of 0. What is x of t Laplace? X of s. Alright, so you can see over here x of t is equal to 0, x of s is equal to 0. So x of s is equal to 0 means this goes away and this goes away. Alright, what is x of 0? X of 0 has to be some value, but I don't find any value over here, so I will not use any term over here. So what remains, guys? What remains? Only these things remain. Fine. Y of 0. What is y of 0 value? You can see from the sum it is 1. Y dash 0 value is given as 2. Very good. Y of 0 value is what? 1 from the sum. That's it. Okay. Let us simplify then. Therefore, s squared y of s minus s minus 2 plus 5 s of y of s minus 1 plus 6 y of s is equal to 0. Therefore, if you rearrange, you will get y of s is equal to s plus 7 upon s plus 2 s plus 3, that is equal to 5 upon s plus 2. Take partial fractions. Therefore, if you take the inverse Laplace transform, what will you get the answer as? Y of s inverse is y of t. 5 upon s plus 2 inverse is e raised to minus 2t u of t minus 4 e raised to minus 3t u of t. Okay, so we have taken the inverse Laplace transform of this entire term. Fine. So what response is? This is your natural response. We can write yn of t. This is your natural response that you have got. So you have got your ZIR, that is your transient or your natural response. Okay, so first job is done. Next, let us find the zero state response, please. Okay, let us find the zero state response. Okay, same thing again we must do. Okay, same thing again we must do. Second is to find the zero state response or steady state response. What is to be checked over here? All initial conditions 0 and input is taken. Fine. So now my sum is y double dash of t plus 5 y single dash of t plus 6 y of t is equal to 2x dash of t plus x of t. Okay, let us take the Laplace transform for this. So you have unilateral. Okay, please, unilateral, don't forget please. S squared y of s, we have done this already, minus s y of 0 minus y dash 0 plus 5 s y of s minus y of 0 plus 6 y of s is equal to s x of s minus x of 0 plus x of s. Fine. Okay, so what do they say? They say all initial conditions are 0, means y of 0 0, this is 0, this is 0. Alright, x of 0 not given, so 0. X of s, is it 0? No, because we have to consider the input. Okay, now one thing, they have said input is x of t is equal to u of t. They're given input as this. So what is x of s, guys? It is 1 by s. Let us substitute and see. And what remains? S squared y of s plus 5s y of s plus 6 y of s is equal to 2 s into what is x of s? 1 by s. Plus x of s. What is x of s? 1 by s. So what remains over here is y of s, s squared plus 5s plus 6 is equal to 2s plus 1 upon s. And that is x of s. Okay, no x of s, we have already substituted x of s. So what remains? Therefore y of s is equal to 2s plus 1 upon s, s squared plus 5s plus 6. Okay, so take partial fractions. S squared plus 5s plus 6 is s plus 2s plus 3. Take partial fractions, you will get at the end 1 by 6 s plus 3 by 2 s plus 2. Please do it, please. Okay, s plus 3. Last step now to get the inverse Laplace transform. So y of t is equal to 1 by 6 u of t, yeah, plus 3 by 2 e raised to minus 2t u of t minus 5 by 3 e raised to minus 3t u of t. So what is the response? Well, this response is your forced response. Okay, so you can say yf of t. So I have now got two answers. One is 0 input response, next 0 state response. Yeah. So at the end you will say, therefore final total response y of t is equal to y natural of t plus y forced of t. That is equal to what is y natural of t? 5 e raised to minus 2t u of t minus 4 e raised to minus 3t u of t plus force responses (1 by 6 u of t plus 3 by 2 e raised to minus 2t u of t minus 5 by 3 e raised to minus 3t u of t. Yeah, so this is the final answer, and this will come for 10 marks, and it usually comes in the exam. So please mark this as very, very important question for your examinations. Very, very important. Okay, this comes for 10 marks, and it is very, very easy to get the answer. Fine. That is it. That is the end of Laplace transform. I hope you enjoyed these two lectures online. We'll come back with more. We have to finish off DTFT and Z transform also. Okay, so meet you guys in the next video. Thank you.